but yeah, you're not going to look at me. I'm ugly as hell, and I'm sure Emma and Vicky will take care of this. So,
We hope you feel better.
thank you.
So, yeah, so I have Alex's slides, but I don't know that I can do full justice to these slides. I will try because I just took a very cursory look at them. And Emma, can you just make sure you let anyone else in? And can you just confirm on your screen you're seeing that I'm recording has
Yep, I see
started?
the recording. I
Okay,
see the
cool.
slides.
Okay.
I'll let people
Okay.
in.
Okay. And so I'm really sorry for those of you who came to listen to Alex because none of us can match him in terms of like style. But hopefully we can try to do some justice to this content. And I'm also very sorry. I only looked at this set of slides like 3 hours ago. So, so if I say something very wrong, feel free to like correct me because it's always hard to talk when they're not your own slides. Okay. So, Calvin and Hob, there's never enough time to do all the nothing that you want. That's very much me. Um, and so, as Emma will know, I just basically vegetated last night, fell asleep as soon as I got home, and then
Yes.
woke up at about like 1 a.m. and then watched Chinese soap operas while I try to get work done. Okay. So we are on video. I just wanted to remind everybody this is going to be posted to YouTube. So if you don't want your face or name seen, please hide them or change your name to something else. So reminders, okay. This past week, Emma and Dieter both had office hours, and these office hours will be recurring weekly. Um, and so they're not going to be like the campfires, they go on for 4 hours. They'll only be like 1 hours. And so hopefully you guys will take advantage of them and go and talk to Emma and Dieter and pick their brain. And there is also an opt-in Gmail reminder. If you want to get reminder in the format of a Google Calendar about the upcoming sessions, okay, you could enter your Gmail. This is in the linked post on the forum. I'm not going to sell your Gmail to like a third party. And so it'll be completely just used for Life After Code in Place. Okay, and then just a preview of the upcoming schedule. So we're in week 10, and so past the halfway mark. This is today. And we do have a session next week. This is next Wednesday. I'm sorry, this is so like back to back, but at the time that we made this schedule because of Alex's work and travel schedule, he basically had to do them back to back. And so hopefully he'll be well enough to come back Wednesday so that you don't get me again, which is a subpar version of what he's capable of doing. And then the following week, Emma's going to talk about API and the infinite story assignment. This is a relatively new assignment to CS 106A. We don't expect people to have done this assignment because it does involve like a ChatGPT key. And so you could just come and learn about API and then we can work through the assignment together. That was your plan, right, Emma?
Yeah, that's the plan.
Okay. Okay. And then we'll have like a 1 week hiatus so that you guys can get caught up on all of the material. And then we move into nested structures. And so I would say nested structures like the 2D list is a relatively complex and but very important topic. And I did like post the recorded videos and the slides and the assignment on nested structures. So highly, highly encourage you guys to take a look in advance on nested structures. Okay. Hopefully, strings today is not going to be that long so that well, and the assignments are not that complicated. And so hopefully I can give back some time for you guys. Okay, so quiz time. As some of I actually signed up for like a 1 month free shipping on Zazzle. And last week, Nick, who's one of the SL, actually cheated because he actually saw like part of the answer on my slides. And so this week I hide the answers very, very well. So we're gonna try again, okay? We're looking for three things: the name of this place, the city, and the country. And Emma and Dieter, I actually cannot see anything in the chat the way I'm sharing this screen. And so please help me monitor the forum, okay? Um, Basically, the first person who comes up with all three correct answer, you can have your pick as to a color and size of your choice of SIP 2025 t-shirt. And so Emma and Dieter, and also Alex, if you feel up to it, you guys can enter too. This place is not easy, or you could get the equivalent of like a $15 Amazon gift certificate, but you must get everything correct. And I'm going to time it for 30 seconds. If nobody enters anything in 30 seconds, we're just not going to have a winner. Okay. I mean, I kind of wonder if I should do like the lottery format. Like every week we don't have a winner, like it builds up. And so by the end of the month, you could get like a whole bunch of like, so t-shirts. Although I don't know why anybody would want like more than one sub t-shirt. Okay. So, anyways, get ready. Okay. Here is the picture, this place. So we want the name, the city, and the country. I hear typing. Oh, see, I actually even like have a built-in, safeguard in case I accidentally randomly click something, so the answer wouldn't show up. Okay, let's see. I want to
Okay,
see.
so I entered an answer, but I also wanted to say, Vicky, there's a message in the chat about the schedule for nested structures.
Oh,
That the invite
okay.
was sent.
Okay. All right. Andrew, thank you for letting me know. I will double check and then correct that if it's wrong. Oh, I love this. Okay. All right. So, Emma, feel free to try again. You're very close. Okay, but it is not Shinjuku. Hold on. Let me consult the expert. Okay. Hey, Bill. 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 Hey, Bill. Is the Shinjuku the same as Shibuya? They're not, right? Okay, yeah, okay. Sorry, Emma, I would love to give it to you, but the expert says Shinjuku is actually a different part of Tokyo. So,
But there
so
is an answer with Shibuya.
I know. But I was hoping like Emma would actually win. So, anyways, okay. The right answer is actually Shibuya. This is actually known as the Scramble Crossing, or otherwise called Shibuya Crossing. And the city is in Tokyo, and this is Japan. So, this crossing is known as the busiest pedestrian intersection in the world, with as much as 3,000 crossings every 2 minutes, which is the length of the green light. And then right next to this crossing, there's actually the statue of this dog, which is a major attraction in Japan. This dog is named Hachiko, and it's in Akita. And so between 1925 and 1935, this dog would actually run off to the Shibuya train station every day to catch the 3 p.m. train because that's when his owner used to come home on that train. But unfortunately, his owner has like passed away. And so the dog did this until like actually the dog died. And so there's actually now a statue of Hachiko that stands next to the Shibuya station. And I believe they actually preserve the actual dog as a stuffed dog in one of the museum in Tokyo. Sharon, congratulations. You can send me like a personal message in the chat with your email, and then I'll contact you. And then you can also tell me if you want the gift certificate or the t-shirt. So we'll try again, next week. Okay. I already have the location picked out, and then next week it's gonna be hard too. Okay. Okay. So today we're going to talk about strings. And so I think what Alex had planned is a very extensive deep dive into all the minutiae of how to work with strings, which should take about 40 minutes. But given that I talk like the Bullet Express in Tokyo, maybe it will take me 30 minutes. And then we have 4 problems. I don't think these problems are terribly difficult. And so Alex originally wanted to do all 4 problems in one breakout rooms. I mean, if you guys don't have a preference, what I was going to suggest is that we do one problem in breakout rooms, regroup, and then do the second one in breakout rooms rather than just do all 4 all at once. Do you guys have an opinion as to whether you do like 4 separate breakout rooms or just one huge breakout rooms and let people loose? Emma Dieter? Four, 4 separate ones, right?
Yeah, I think so, because then you can regroup when everyone's done
Right.
with certain things. We can kind of figure out where we are.
Right. That was my thought as well. Um, and and also, that way, if somebody has completed one problem and not all 4 problems, they could like choose the appropriate rooms. We will probably end earlier. I just split 2 hours into three. Okay. All right. Okay. So, strings. The one thing I will say about strings, just from my personal experience, is I feel like a lot of the string functions are very similar to list. And so this is also a good time to sort of review some of the list functions. Um, and so if you can do list, you can do strings. Okay. Okay. So, Alex says strings are sequences of characters enclosed in quotation marks, whether it's a single, double quotes, or doc strings. And so when people talk about strings, I think most people conjure up this image of characters, but they don't have to be characters. They can be anything that's enclosed in single or double quotes, including like numbers, symbols, etc. Okay. Okay, so these are some message examples of strings like hello, my name is Inigo Montoya. You killed my father. Um, be prepared to die. So the first one is enclosed in double quotes and it contains punctuation marks. Also, white spaces also count as strings. The second one is a single quote And the third one is like these doc string with like multiple quotes. Okay. Um, this may be obvious, but in case it isn't, it doesn't really matter if you use like single or double quotes. However, you cannot mix quotes, okay? Which means you cannot have like one single quote on one side and the other one that's a double quote, at the end. If you're gonna use single quotes, use single quotes, and then double quotes, use double quotes. Okay, so similar to a list, strings can be indexed. And so there's the forward index, and this pertains to all of Python. If you do the forward index, you start at 0 and then you go positively. But you could also reverse index. And so if you do the reverse index, you always start at -1 and you start at the last element and then you go backwards. And then the numbers become more and more negative. And so you can see based on this picture here. Any questions so far? Okay. So, okay. So if we look at this message, if we have a variable called message, and then we save a string called prepare to die with a period into this variable, and then we have a command that says print message at the 0 indices. Okay. This is the very first character within this string, and so that will return a P. Um, okay. So can somebody just shout out or put in the chat like what would this one print you?
We're getting lowercase t in the chat.
Lowercase t. Okay. Yes. Yes, that is correct. And then what about print message -4?
D. Everyone says D.
Yep. Wow, you guys are so smart. Okay. I love the participation. So, that way I don't have to cold call on people. Okay. So, this is a little bit tricky. What would this print?
Uh,
If I get no participant, people know I'm not shy about calling people.
Uh, People call it error.
Yeah. Okay. Yes. And so this is kind of like out of range. So yeah, this one would give you an error. And then similarly, if you have -16, this is also an error. Okay. All right. So what does this one shows? Okay. So, like list, okay, we could also do slicing. And so, if you guys remember what slicing is you basically designate two indices, and then the function kind of like lift what's between those two indices. And the thing about Python you want to remember is if you're
I
using,
don't know what.
huh?
Nothing.
Okay, sorry. Um, is that if you're using slicing, okay, the first number is inclusive, which means it will always include the one, okay, but the last number is exclusive, and so it will not include the four. So, what would this give you?
The usual suspects already answered as soon as the your slide changed. RAP is the answer.
Okay, all right. I feel like I need to call on like the non-usual suspects. Okay. So this one, like if you have 4 to -8, anyone? Yep. Yep. Okay. And so this will go from A, R, E. And then does not include this white space, okay, because it's exclusive. So question, can positive and negative be used together? Well, I guess the answer is yes, because this example basically has positive and negative used together. So, I didn't realize this until I saw this example, but belly cough is always right. So, if he says it can be used together, they can be used together. I would have thought this needs a negative step in order to work. Uh, Probably not. Emma, Dieter, do you want to comment on that? Because I don't normally write it like this, but um,
I also wouldn't normally write it like this, but I do think that this would work.
yeah.
Um, I also,
Yes, and
I can confirm that this would work. And as for the negative step, you would use a negative step if you want it reversed, as someone put it and put it in the chat.
and you'll get to that in the slides.
Yeah. Okay. All right. I realized Belikov is not a co-host, so I just made him a co-host. Okay. So moving on. Okay, so this goes from -7 to -1. Yep. So let's see. Yep, this is to die. And then it's important that this does not include the period because um, the last one is usually exclusive. Okay, this is a good one. Okay, so if you start with 11 here, but you don't specify an end condition, what happens here? This is just like a list. Yes. Yes. Okay. So I see die with the period. Yes. If you don't specify an end condition, okay, this will just go all the way to the very last element or character in this case. So it would be die with the period. Okay. So what happens if you don't specify a beginning? Where would this start? I guess is the question. Yep. So this would be prep. Okay. Again, excluding position 4, and so excluding this A. And so it's prep. Okay. Okay. So if we have 12 to 1000, what would this return? This I am actually okay. So we have some people say error, and we have some people say it's gonna return um IE. Yeah, this is tricky question. Okay. I actually forgot what the answer is. But I think I would actually vote for error. And so let's see if that's right. Okay. I was wrong. Okay. So this, Alex, do you want to say why this doesn't return an error?
Uh, Sure. I mean, I have no clue why, but when you slicing if the index goes out of bounds, it just goes until the beginning. Or if it's the other way around, or sorry, the end. And if it's
Yeah.
the other way around, you have a very large negative one and it goes to the beginning. So unlike a specific index where you'll get an error, a slice does not give you an error.
Okay. Okay, so this construction, okay, sometimes you'll see like a triple slice construction with a third number. And so this third number usually represents the step. And so most of the time we sort of ignore this number. And so if we ignore this number, it will just step up or step backwards by one. But if we say two, okay, this will actually skip and then skip a position and then step up by two. And so it will go start at 9 and then skip this white space, capture the D, skip the I, and then capture the E. And so, yes, I think ode is exactly the right answer. Okay. Oh, and then we have an example where you go from 4 to -14, but you are stepping by -1. Anybody have any? Yeah. So Demetrios, I think, yes. Okay. So, this is ape, because the -14 position is actually exclusive. Okay. So hopefully we've beat that to death. Okay. And so like everything else, like all of the other data structure we've talked about so far, looping is very, very important because at the end of the day, computers is supposed to make our life easier. And so computers are very good at doing a job repetitively. And so if you guys are reviewing these data structures, I think it's very helpful to like review the syntax as to how to loop. Okay. Um, the slice works exactly the same for NumPy. Oh, cool. Like, um, so like for list and dictionaries and for images, okay. We could loop using positional indices. And normally, if you're looping using positional indices, the syntax will have like the word len in it, okay? Because len basically um, um, like tells you like the length of it. And so whenever you see the word len, it should clue you in that it's probably looping um, um, uh, using the positional indices. Okay. The second way to loop is if you were to loop by the characters. And so with the characters, you actually don't need to call them. You don't need to refer to using the positional indices. So let's see how the syntax work. So if you're iterating over the indices, okay, usually this is like for I in range, like len, the name of your string here is message. And what I like to do is, when I try to parse out this syntax, um, I try to figure out, what is exactly Python syntax and what is user defined. And so here, I and message are user defined. And so I could change I and message to anything else. I could change it to XYZ or ABC. Okay. As long as you keep it consistent, this should still work. And so everything else that's outside of the yellow is not changeable. Okay. And then here, for each iteration of the loop, we're asking um, the computer to print something. Okay. It's going to print this message in the square bracket I. This is actually going to print whatever string is at that positional indices. And I think the reason Alex included this thing here, okay, is because usually when you print a line on the computer, there are these hidden like spaces, which is like a /n. We don't really see them, but the computer knows that they're there. And so it kind of tells the computer to sort of wrap around to a new line. But if you were to add this command like end equals something, okay, it prevents it from wrapping it around into a new line. And so you don't necessarily need the dash here. You could just um, change that dash to, I think, like a, white space, or no space at all. Um, Whatever you put in this colon here, I think, will kind of like delineate in between each character. I don't know if that makes much sense, or if I explained that right. I'm a um, dear, yeah. Okay. Um, Alex, did I get that
I,
right?
I, I confirm everything you said. Yes,
Okay.
I did this for the simple reason so that it does not go vertically outside of the slide, actually.
Oh, okay. Okay. All right. Okay. So the return output you'll see here is hello. Okay. It will print each character with the dash in between. If you don't have the dash, if you just left it as like a blank space, it will instead have the blank space.
Emma, thank you for correcting yeah, there should be a dash at the end. That's my mistake.
Yeah. Okay. Okay. And then the second way is you can iterate over characters. And so if you're iterating over characters in here, okay, the character and the variable that holds your string are user definable. You can call them anything else you want. Um, but this for in construction is the Python syntax that's not changeable. And so this construction basically will give you the same output. Oh, thank you. Thank you. Okay, it should give you the same output, but of course, we're also missing the dash here at the end. Okay. Um, okay, like that. Okay. Any questions? All right. Okay, okay. So the other thing you can do with string is you can concatenate, which means like mush strings together, okay, using this plus sign. Although if you're concatenating strings, sometimes you have to pay attention to where you put your spaces because I don't think it automatically inserts the space for you. And so we basically have these two strings, message one and message two. And then if we were to concatenate them together with a comma in between, okay, and then save this to a new variable called new message, okay, and then printed, it will look like um, this, okay. Um, and if you don't want this white space here, you would have to make change to the parentheses here and get rid of the space here. As most of you guys probably know, having struggled with the auto grader on the IDE, this is a very, very frequent occurrence. Whether you have the extra space, whether you don't have the extra space, it makes all the difference in the world to the auto grader. But in reality, it probably shouldn't. Okay, so here we have another string. Okay, so here is a very long slide. I think for the sake of time, I'm just gonna like um, show all of these, and then we'll just kind of go over them very quickly. Here we have a string, and then this string has, I believe, two white spaces in the beginning and two white spaces at the end. Okay, this is important because there are all of these, functions you can use with a string. Because I'm getting old, I can never remember the exact syntax. And so I don't think you guys need to memorize this list. There's probably more that Alex didn't include on this list. I think it's just important to kind of know like these commands exist so that when you need to use them, you can always Google and find them. Because we're not like in third or fifth grade. We're gonna get like tested on the exact syntax. Okay, so basically, what this strip um, does, okay, is that strip will remove the beginning and trailing white spaces. Okay. It's important to keep in mind that strip does not get rid of white spaces in the middle of the string. Okay. There's actually another way to do that. I believe there's a command called replace. Okay. That's not on this list. And so if you want to get rid of the white spaces like in between these words, you could actually remove the white space with a non-white space, and then it will kind of mush everything together. But strip, just know that strip only works at the beginning and end of a string. It doesn't work within the string. Okay, and then split. Okay, so split basically splits up the words or splits the string according to whatever you tell it to split as. Here, split is trying to split between the white spaces, but you could also put in like a comma there. Okay. And so next week when we work with files, we'll talk about the comma delineated files like the CSV files. And so this command like split will be important because you could insert a comma in there and then it will help you kind of split each element within the CSV file, into like separate bins. Okay, so
Vicky, can I just
yeah,
interject
yeah, of
just
course.
a couple of words about the strip method because I saw Emma write it in the chat, and I think this is important because one of the most important reasons for using strip is when you are reading data from a file, and by default, these strings will have a trailing /n, so they will have the new line character, which you usually do not want to be there. So strip is usually used by default when you are reading data from a file in order to get rid of those extra new lines that you do not want to store in your variables.
Okay, thank you. Um, so the next is find. Okay, and so find will return the positional indices where this substring is occurs. And so the reason why this is position 4 is because we have two leading white spaces that are at position 0 and 1. Um, and then T is 2, H is 3, and so the first is starts at position 4. Okay. And so this will identify the first match. Okay. Um, Although is occurs again, it will pull out the first is. And then this one, find boo. Since boo is not there, it will return -1. I didn't know this. Okay. And so upper and lower is useful because upper just converts everything into uppercase and then lower converts everything into lowercase. It is important to remember that Python is a case-sensitive language. And so if you have the same string and they're in different uppercase mixtures, Python will treat them as non-equivalent. Okay, so this one actually kind of confused me a little bit. Um, okay, and so is alpha is a command to test whether or not um, you know um, a string contains, I believe, all characters. Okay. And so I did not realize why this is actually false until I consulted my best buddy, ChatGPT. And so the reason why ChatGPT said this is false, okay, is because it has like white spaces and I believe punctuation marks. Um, and so for this to be true, okay, you cannot have these leading and trailing white spaces. And so Emma, Dieter, do you guys have anything to add to that? Okay. Um, Whereas if you were to do check just words, okay, this has no punctuation marks and no spaces. Um, Python will think, yes, yes, this is all true. Okay. Basically, these are all characters. And then the flip of is alpha is digit. Is digit basically checks if a string is all numbers, okay? Um, and so obviously there's not a single number in here, so that's false. And then if you have one, two, three, four, five, this is obviously a digit. Okay. Okay, so
Can I just talk a bit about isDigit or why isDigit is an important method when
sure.
you do command line? Uh, there are often cases when you ask the user to input a number, an integer, and then you want to turn that integer from a string into from a string into an integer using the int function. But if for whatever reason the user mistakenly enters like letters or something else, the code breaks and the program just crashes. So the isDigit method is often used to check whether a string contains only digits before actually using the int function on it. And this allows you to prevent your program from crashing and instead give some sort of message saying this is not a number, please enter a number.
Okay. Um, so I think the second to last concept Alex wanted to talk about is this function called ORD. This is not, the Chicago O'Hare Airport, whose abbreviation is also ORD. I basically grew up in Chicago, and so, I'm very familiar with ORD. What ORD gives you is it basically gives the sort of like ASCII Unicode equivalent of every single character. And so apparently all of these characters on our keyboard has a sort of ASCII Unicode equivalent, and they're assigned a number. Okay, I'm not sure what this hex or oct is. It's probably something I never use, but um,
It's hexadecimal and octal, so base 16 and base 8. So you have the three numbers in base 10, base 16, base 8. They're the same number.
okay. Okay. So, anyways, ORD, I believe, gives you this um, DEC. Okay. There's probably an equivalent command to pull out the hexadecimal and the octal, but I have no idea what that command is. And I forgot to ask ChatGPT. And so if anyone is curious and know it, you can type it in the chat. So basically, if we have this print ORD message um, at indices 0, okay? At indices 0, this is H, and it's big case H, okay? And so big case H and lowercase h have different numerical ASCII representations, okay? And so this is going to pull out the numerical representation of big H, which is number 72. And then this other one is like lowercase e at position 1, and this is number 101. And so why do we want this, or why is this, important. Okay. I mean, I think this allows us for a way to like compare different type of strings. Okay. Um, I mean, I think in the English language, we always think like, okay, capitalization is more important than lowercase. And so if I'm comparing like big A, little a, big A is probably bigger, but this just gives us like a quantitative way of like comparing different strings. Okay. Um, Basically, if you're like comparing, like say big A versus um, big B, I guess, big A's number is 65 and big B is 66. And so big B actually has a higher higher, ASCII value than A. And so this statement would be true. Okay. Um, okay. And then small a is less than big A. I think that's false because small a is 97 and big A is 65. Okay. So I think that's all there is to that. Okay. Oh, what happens if you have more than one character? I believe if you have like more than one character, um, would they compare like the first character and then see which
Yes.
one is greater, right? Okay. So so, so here, the lowercase d is greater than the lowercase c, and so dog is actually greater than cat, even if not all of the remaining characters have to be bigger than the remaining characters in cat. They would just compare that very first string character. Okay. All right, yeah. So, okay. So, oh, and then one other thing that we talked a lot about these data structures. I think it would be helpful if you guys make like a chart for all of these data structures we talked about, like how to loop over them, using the for loop and whether they are mutable versus immutable. And so lists and dictionaries, they're mutable. Okay. Strings, on the other hand, is actually immutable. So what does that mean? Okay. So if this were a list, okay, we could actually reassign a different element to the indices and it would actually change the list in place. But because this is a string, okay, even if I were to type this command, which seems like a grammatical Python command, okay, it will not replace the P with the E. Okay, this would actually give you an error. Okay. Um, and so how do we change this from eat me to pat me? Okay. So because strings are immutable, in order to change the strings, you actually have to actually redefine the the string or to actually concatenate your string with some new characters such as here. Okay, you could either concatenate p into your message and then start at position one, which means just exclude the e, and so the p would be added to pat me, and then if you print this. Oh,
Yeah, this
uh,
is a bit of a trick
yeah, yeah, yeah.
because yeah, you understand why.
Yes. I understand why. Okay. And so if you add the P, start add message at position one, okay. But if you print the variable message, because the strings are immutable, the string itself is not changed. That's why it's still print eat me. Okay. Um, Okay. However, if you want to create a new string that actually says pat me, okay, you can save it to a new variable called new message. And now, if you print the new message, this should print pat me. And then if you print the original message, this will still print eat me. Okay. And is there anything else? Okay. And so here, if we were to redefine what's being held in the variable message using the concatenation P plus message starting at position one and then print this, okay, this will rewrite what's being held in the variable message and print pat me. Okay.
Yeah,
Okay.
so a very quick comment on that because before we go into problems, so the idea is even when you reassign it to the same variable name, it does not mean that you change that specific variable. You're actually creating a new string. So the new string is then stored under the old variable name, but actually in the memory, it's going to be in a different place. So it's not the same as in a list you change in place. You actually place it in a new memory position.
Okay. I am trying to figure out how I can, oh, there it is. Okay, so we're gonna do, sorry, keep on like randomly clicking through my things. Okay, so the first problem is this double character problem. Okay, we're gonna implement this function double character, which takes in a string s and return a new string with all the characters doubled. So for example, if we have boba. Uh, we're gonna double every character, and so this becomes BBOOBBAA. Okay, seems like a pretty easy assignment. I'm gonna. Okay, where's my breakout room button? Sorry, like, I feel like my window just randomly appears and disappears, and I don't know.
I can set them up.
Yeah.
What
So,
what do you want to do?
and so we're still gonna have like three breakout rooms, well, three groups, okay. The people who've done the problem, and then people who didn't complete the problem, regardless of whether or not you tried it or not. And then if you are like socially introverted like me, you could just hang out in the main room. If you're having a bad day, you don't want to talk to anybody, just hang out in the main room. We won't bother you. Alex, are you up to manning a breakout room or you just want to sit out and go rest?
If there is a need, I can
Okay.
certainly do it.
Well, I mean, we can just well, I mean, I think we can do it without you. And so why don't you take care of your health? And so Emma, we can just have the three of us. One person can stay in the main room and then one can go to the completion and one can go with the people who didn't try it.
I will certainly stay in the main room, so you can actually leave me here if anyone has any questions.
Okay. All right. Okay. And so we can set like about 10 minutes for this problem and then we can regroup. Okay.
Okay.
Um,
I opened the room.
the recording. Okay. Um, so if nobody is gonna volunteer, can I cold call on somebody? I forgot who's actually in the completion room except Martha.
Don't, don't.
Uh,
Sure. We were chatting about the last problem in the breakout. So let me know if you cannot see this.
Do you mind zooming in a little bit?
Let's see. How do I zoom in?
If you're on a Mac, you're on a Mac or PC. I don't know how to do it on a PC, but
Let's see. Okay, Control Scroll does not work.
Command Shift plus might work.
Which one?
Command Shift
Oh,
and plus.
Command Shift plus. Okay. Where is the plus? There we
Oh, you're
go.
on Windows.
Nope.
no, that works in VS Code, but
Oh. It's a VS Code thing.
yeah.
Let's see. Okay, we need a quick Google. How do we Google zoom in on PyCharm?
well, that's okay. You could just probably talk us through it. I think hopefully most people can see it. I could just squint. It's fine.
Or I can share the solution that my group worked on.
Yeah, maybe Dieter should do that um, so that everybody can see.
Okay.
So I'll replace your share,
Yeah,
sorry.
yeah.
You can see it?
Yep, you can see it.
Let's see.
Okay, so somebody in my group should speak up. We tried different ways of adding the two characters, and they all work.
Somebody in Dieter's group.
Yeah.
Okay, so
So
I was there and I had this doubt, and but let me just walk you guys through it. So what we did was like we created a new string, new words. It's an empty string, and after that we created a for loop, and we use the character for loop style that Wiki taught us, and just every time looping through the string, we added the like two, like we multiplied it by two, the character that was in the loop, and added the previous new word, so that for example it's empty now, but afterwards if I have like h, it will be added to, so and assigned it to new word again, and then we returned it. So that was it.
Excellent. So, just to summarize, thank you. That was a beautiful explanation. This is exactly how I did it. Okay. Basically, in the function, you need to define a new empty string, and then the goal is to populate that new empty string. And then we have this for loop. It doesn't matter what you call ch, what you call s, okay? But whatever you call s, that has to match with the parameter you're feeding into the double character function. I think the main takeaway message for me in this problem is like normally we don't think we could like multiply or add string characters, but you actually could actually multiply characters to kind of double them. Okay. Basically, each iteration as you're looping through the character, you're basically just doubling that character and then adding it to the um, string new word. And then I think Alex had something to say. The first,
I answered
yeah, yeah,
Carlos's
okay,
question
okay,
why these two things are different, and I actually like Dieter that you have like in 16 and 17 two different ways of doing it, but you can actually combine them and do new word plus equals
got
2
it, got it.
multiplied by ch.
Okay, yeah. And so, just in honor of Alex being here when he's like so sick and so dedicated, and to kind of like whet your appetite for like a couple weeks from now. I think that's the lecture after nested structures. Okay, we'll talk about something called list comprehension. This could actually be written with a one-line code. I will put in the solution in the chat, and then I'll also include it in the solution. I will post onto the Google Drive. Okay, I never fully understood list comprehension, so I am looking forward to learning more about list comprehension this time around. But you you could basically combine the for loop, okay, with the multiplication or duplication of the character all in one line, and then use this function called join, okay, and then return this entire like mess, okay, um, basically as a return of your double character, and this would also work. Okay, excellent. Okay, so any questions about that, or does anyone else have a creative solution?
Yeah,
Sure.
we had a discussion, sorry, in our room about the memory locations, and in each iteration, are we assigning a new memory location where the new word remains, and do we fill up memory, or what's happening? I think that's a question to Alex.
Yeah, that's actually an interesting question. And this is something that you need to bear in mind when you work with strings in general. Uh, obviously, when you do small programs, it doesn't matter. You will not be able to fill up memory. But when you are, and it's more, I think, actually not about memory, it's more about speed, because every time that you create a new string and store it in a new location, that's slower than doing something in place. But to answer this specific question, the first answer is yes. Each and every time we inside the loop, we do new word equals new word plus whatever, we are creating a new string and a new location in your memory. But then the second part of the question, are we actually filling up memory? And, if we do this long enough, we'll just run out of memory. And the answer would be, in this specific case, no, because when we are saving the new memory location to the variable, we are actually freeing up the old location because there is nothing else pointing to the value which is in that location memory. And Python is one of the languages which actually cleans up your memory automatically. You don't have to do it by hand, unlike, for instance, C, or I don't recall whether in C++ you actually have to do it by hand. In Python, you don't. So that part of the memory will become free. So the answer to the second question is no, we're not filling up the memory. We're just taking up one space but freeing up another space, if that makes sense.
Thank you.
Okay. Great. Any other questions? If not, I think we've beaten this one to death. So I'm going to share problem number 2. Um, okay. So problem number 2. Okay. So problem number 2 is the caddy problem for those who love cats. Okay. Um, Whoa, what is going on? Okay. Okay. So for problem number 2, we're basically implementing this function called caddy, taking in a parameter s, which is a string, and then returning a new string that contains only the character uppercase cat or lowercase cat. So I'll give you guys a hint. There are multiple ways to do this problem. I thought of at least 2. Okay, and so the example would be if we have this string tacos are tasty, and then if we feed it into the function caddy, this will return tacatat. Okay, we'll do breakout rooms again. I think I can actually create the breakout rooms this time. Um, Let me see. Whoa.
I just opened, sorry.
Oh,
I was in the middle of opening them as you were saying. I figured it would be almost the same people, and if it's not, people can move.
okay. Do you have 2 breakout rooms or 3 breakout rooms?
I made a third room just in case we did want to move people over.
Okay,
What do you think
cool.
about that?
No, it's great.
Okay.
So go.
No pressure.
No pressure.
All
We're all
right.
friends.
So we had several different options, and it was cool to see how we iterated through. So let me comment out. And so the first way that we did it, I think we were noticing we all did it with for loops. We were just starting to discuss. If anybody had considered doing it a different way, but all of these are for loop examples. And so the simplest brute force one was to walk through for each character in the string. Um, uh, is it equal to the lowercase or the uppercase C? Same thing for A, same thing for T, and then just concatenated on, added on to our empty caddy so that every single time we find one, we add it in order. And then the print statement is just because I like being able to see things so that doesn't, the doc tests won't like that. And that passed the doc test. But that was annoying because if you had a longer string or if you had more letters, then it was going to get into being a very long uh, um, if statement. So then I tried doing it with using just the lower and using just lowercase c, a, or t. That also worked. And then a couple folks in our group did it with lists. And I was just starting to try and frantically type that in here so that I could play with that. And think, I'm not sure if I actually got this working. No, I don't want the
It looks legit.
so we were just starting to iterate closer to, okay, well, a list is fine. And then we were just starting to ask the question of could I just search for the characters in the string itself without having to break it out into a list and just say, hey, if this character is in my target list of CAT, capital CAT, do I have to break it out like this? And we hadn't gotten past that point of could I just search in, a string of random characters that have the characters that I want to search it in. So that's
Yeah, this is actually a very good idea, and it's a correct idea, though there is a small caveat that you need to bear in mind. You could have written, yes, if ch dot lower in, and then take a string which has three letters like cat, it would work. In this specific instance, it would work perfectly. Uh, the reason why it would work perfectly is because you know that ch will always be one character. Because when you iterate over a string using a for loop, it will go character by character. But you have to be very careful with this specific algorithm, for instance. If you are searching for something which could be more than one character in length. So, for
uh,
instance, if a person inputs something on the keyboard and you sort of expect the person to enter one letter, but the person enters like three letters. For instance, if a person writes cat, it would still be true because cat is in cat. So if you want to make sure that you're only looking for one specific character instead, like of a substring, then the way you did it right now is more secure. In the sense that you will know that it's only one character and not a combination of characters like CA or AT or the entirety of CAT. Does that make sense?
yeah, yeah. Cool. So it was really cool seeing how many different solutions we could come up with, and it sounds like there's still more ways we could solve it.
Um, can I chime in for a second? Because I actually had a question about this problem. Okay, I'm going to share my screen. Where the heck did my screen go? Okay, so the first way that I did it is I actually defined a global string on top, okay, that encompasses both the lower cat and the uppercase cat. And so the first way that I did it is, in the subfunction catty. I basically defined this empty string that we're gonna populate, okay? And then we loop over your parameter s, which is the input string. And then I basically check each character in the input string against my global string, which is character here. Okay, that's kind of like the similar concept with having a list. You can check against your list. I don't think it has to be a string. And then you just populate your empty list, okay, with characters that matches your global character. And then the second way, which I'll also include in the solution, is you can convert everything kind of into lowercase um, um, or uppercase, okay? And then you can search for it against the word cat, either lowercase or uppercase. But my question is this, okay? Um, Dieter, Emma, Alex, if you look at my line 18, when I write this, if character in character, okay, I'm checking against my global string, okay? This, what I wrote here worked. However, if I were to change this to if character is double equal to character, it does not work. Why?
I would actually ask. I see Anna is already answering in the forum, and it's the correct answer because you would be comparing a single character to the entire string, and they would be false. Unless, of course, your character global constant is one character. In that case, it would work.
Yeah.
But Anna, the second one you're writing, you say it will work if character is cat cat. That will not work as well, because is actually an operator that checks whether two variables have the same memory location. It has nothing to do with checking the equality of the value. It goes beyond that. It's checking whether it's the same value if two variables are pointing to the same value in memory. So yeah, you cannot use equals here.
Yep. Yep. So I did figure it out using my bestie ChatGPT, but I thought that was a good sort of like pseudo learning point. Okay. So any other questions about that problem, or can we move on to the next one? Okay. So now this gets a little bit harder. Okay. So for the third problem, which is find differences, basically, we want to implement this function called find diff, and your parameter is actually two strings, okay? But what we know about these two strings is they have to be the same length. That actually simplifies our problem a lot, and then you can think about why, okay? Um, the problem would be harder if they were not the same length. And so they're taking in these two strings of the same length and then returns the number of indices where the characters are different in these two strings. Okay. Read the problem very carefully because when I first looked at this problem, I thought that I had to print where the indices happened in that they were different. Okay. But that's not what the problem is asking for. The problem is asking for how many positional indices are different. So, for example, if you're looking at the word sword versus crowd, okay, like position zero, position one, and one, two, and position three are different. And so there's a total of three differences. Okay. So I guess, we can launch people back in the same breakout room or they want to change. I mean, I think it's unlikely that if they didn't complete the first two problems that they would have completed this. And then Alex, do you still want to stay in the main room?
Yes, please.
Okay. So, I see Leah's here. Leah, if you want to jump into one of the two breakout rooms, feel free to pick whichever breakout room you want to join. And I'm gonna keep on chowing down my breakfast. I'll see you guys back in 10 minutes. Bye. Okay. Yeah, great.
Okay, good. Okay.
We're good.
Okay, so um define, oh, that's not it. Okay, this is the guy. All right. Yeah, so so result is going to be the number that don't agree, right? And then I loop over I the length that the strings have the same length. And then if the character in 1 doesn't equal 2, then I add to result. So, and then
Beautiful.
return.
Beautiful. In fact, your solution looks exactly like mine. I'm not sure I could come up with a second way to do this. And so essentially what Lori did, and thank you for sharing your code, is basically within the subfunction find differences, Lori defined a counter. And the counter is called result. Okay. And so for those of you that were in my section, we know that counters have a couple of properties. You have to have a baseline value, and so you need to initialize it. And it's very important that the counter has to be defined outside your loop. Okay. And so for those of you who will become section leaders next year, you have no idea like how many people's code on the forum. It's because they define a counter within the for loop. And so if you had put that line 17 inside your for loop, okay, every time your for loop runs, your counter will get reset to 0. And so that's actually a very common mistake um, that you will see. Okay, and so Lori defined this counter and set it equal to 0, and then we enter our for loop. And because both of the strings have exact the same length, and so it doesn't matter if you use len string 1 or len string 2. Okay, the problem would be more complicated if these two strings are not the equal length. Okay. And then within our for loop, we're basically just pulling the indices and then checking the character at each of those two strings to see if they're equal or not. And so if they're not equal to one another, okay, we basically increase our counter by 1. And then that's it. So does anyone else have a different way of doing this problem?
I
Um,
see that Flora has a raised hand.
uh, yes.
Yes, I do. I have a question.
Shoot.
In a result, can can I just use I can't remember how it was. She wrote result equals result plus 1. Can I use oh my gosh, my English is always going to hell when I have to do this thing. Um,
Are you thinking about
count
using?
count plus equals 1 instead of result
Yes,
equals yeah, you get it?
absolutely. Yes, you
Yeah.
can just write result plus equals 1. It's the same thing.
Okay.
Thank you.
Yeah. Okay, great. So, any other questions or ideas as to how to solve that problem? No? Okay. So, if not, okay, well, it looks like we're not gonna quite make the 2 hour mark. I thought, I was on a roll and I'm gonna give you guys like 30 minutes back, but maybe I talk too much too. Um, so we're gonna do this last problem. This is by far the hardest problem, and so I'll give you guys a little bit more time. If you guys have to hop off at 9, feel free to do so. This is the expanded coded string problem. Basically, we're writing this function called expanded encoded string, which takes a string, that's our parameter s, made up of characters and digits 1 through 9 and returning an expanded string. So what the heck does that mean? Where each character is repeated the number of times equal to the digit following it. So if we have something ugly like this, okay, um, B1, it means like in your final string, B is repeated once. And then O2, it means like we're gonna repeat O twice. And then K2, so K is repeated twice. E is repeated twice. P is once, E is once, R is once, and then this exclamation mark is repeated 3 times. And so your new string is going to look like this. Okay. And so same breakout rooms. I'm gonna go take a break, but for the sake of time, I will actually share my solution. So, you can chill. I'm not gonna call on anyone for this, lest anyone think that I didn't do the assignment. I actually did all the assignments. And so, I'll share my solution after this. Okay. So go room free. And I'll see you back in like 10, 12 minutes. Okay. Okay. Sorry. Okay. It's good that I did not get that all that commentary on video because YouTube doesn't need to know that. So, the way that I decompose the problem is I think we need a way to tell if a character is actually a string or whether it's a number. Okay. And since the format of our string is usually a character followed by a number, I kind of figured once we identify a number, okay, we also need some way to go one character backward, to kind of duplicate that string. Okay. And so I feel like that's the sort of key insight we need to kind of figure out in order to solve this problem. Okay. And so the first step I did is I basically defined this empty string called, expand, but you could call it whatever you want, such as like, I love Emma, I love Dieter, I love Alex, or I love everybody. Okay, that works too. And then we're going to use this for loop. Okay. I did not try looping over each character. But I do think if looping over each character probably would have worked as well, but it would have been a little more complicated. Since I realized early on when I was trying to decompose this problem, okay, that once I identify a number, I have to go one step back in order to retrieve that character. That immediately triggered to me, okay, I probably would need to have the indices of their position at some point. Okay. And so I basically looped over like for I in range using the len function, my input string, which is called encoded. Okay. And then what I did is basically as you're looping over every character, I'm checking whether the character is a digit. Okay. And so this format here, encoded I, it starts at position 0 and then goes to position 1, etc. And then at each of those indice positions, it will check whether that character is a digit. Okay. And basically, if you're encountering a digit, okay, for example, if we have this like ugly string here, like B1, okay, once it encounters 1, what we know is we want to go one indice back. And then we want to add this character however many times your digit is into our string. Okay. And so we just have to translate that into a mathematical equation. And so basically, my empty new string is expanded. Okay. And so let's say if I've encountered a digit at position I want to go one position back. Okay. And so that would be encoded I minus one. And so this would give me like say B. Okay. And so I want to repeat B, whatever digit it tells me to repeat. Okay. And so I basically will take whatever string is at this I minus one position and then multiply it by whatever number is at encoded I, and then add that into our empty string expanded. And so you would loop this through the whole entire string and then return your new string expanded into main and then print, and then it should work. The only other caveat I wanted to ask is, okay, can anybody tell me why do I need this int here? Anybody? What happens if I don't have this int? Yes. Anna said because it is a string. Okay. So even though these numbers like one, two, three appears in the string, okay, they're not really being treated as like numerical integers. The computer or Python still recognizes them as a string. And so if I were to take out this int, okay, and run my program, I get an error. And the error is a type error. It says cannot multiply sequence by a non-integer of type string. Okay. So what we're doing here by adding the int in front of these numbers is this is something we learned very, very early in code in place, like lesson, I don't know, one or two. It's typecasting. We're changing how Python is treating these numbers, which is as a string, into a numerical integer class. So we could actually do math on it. Okay. And so once I add this, okay, all the doc test passes and it works. Uh, okay. So any questions about that? No? Okay.
I
Well,
actually like this approach. I like that you actually used one of the string methods. You used isDigit here, so that's a definite plus.
Thank you. I mean, I'm not actually sure if I don't use that, how else um, would one do it? I wasn't creative enough to think of other solutions. And so, with that, if you guys have any questions, I'll stay on for a couple of minutes. Otherwise, have a great Labor Day weekend if you are in the US. Emma, Dieter, thank you for being here. Alex, thank you for being here while you're so sick. Hopefully, you're still not like mad at me. But if you are, it's okay. As long as you get over it by
Oh,
next.
come on, stop airing the laundry. We'll figure this out. We'll talk about this in private. There are
Okay.
actually to answer your question, there are actually a couple of ideas in the chat of how this could be done differently. One from Anna and another one from Dieter that I didn't think about, and I thought it was pretty cool as well. So that's the beauty of trying, to find solutions to coding assignments, even in simple ones. There are so many different ways of doing it. It's not strict science; it's also an art form. So very cool.
Mm,
And don't forget everybody to be working ahead and looking at the materials for files. The
yes.
information's out
There
there.
you go,
The
Martha. Thank
work.
Thank
you.
you, Martha.
Thank you.
Like it took me two takes to do that video, okay? Because um the first time I realized after I recorded there was actually problems in Meron's slides. I can't correct his slides. The mistakes are still there. But I did point it out in the video. Um so um so the files homework is a little more complicated. And then definitely, if you guys have the bandwidth this weekend to start on the nested structure, those assignments gets very complicated very quickly. So definitely, hopefully you guys will take a look ahead as well. And then just remember, Dieter and Emma have office hours. You could come and like pick their brains or just like shoot the breeze, okay, on Monday and Thursdays. So, so that's it. Hopefully you feel better, Alex. Okay.
Thank you.
Have a great
Floor